We are going to be looking at chapter 16, and we will start here. Chapter 16, part 1. We're going to look at conduction and convection, and then we'll have a part 2 with radiation and Newton's law of cooling, and then the greenhouse effect will be separate. So, there are 3 ways that heat gets transferred. Okay, so thermal energy transfer. And those 3 methods are called conduction, convection, and radiation. Now, I think I asked you in an earlier class, if you put your hand on your desk and a hand on a book, one of them will feel colder. And the reason for that is not actually because they're at different temperatures, but because one of them is a better conductor of heat energy. So you're losing heat energy and your brain interprets that as colder. I mean, you'll have to know, when you don't want to lose heat. Humans are working hard to maintain heat to make our body work. So we need to know what surfaces are better if we're going to go to sleep. Do we lie on bare rock or do we put some straw down? So anyway, so yes, so for us, for humans, we care a lot about our heat and how it's being carried away from us. Now, conduction is the transfer of heat energy by electron and molecular collisions within a substance. So the molecules will collide, even in a solid. In fact, conduction is usually considered to be in a solid. So you've got molecules, and what happens is they vibrate. They cause the one next to them to vibrate and the one next to that to vibrate, and that conducts heat from across from where it's hot to where it's colder. Okay, so heat gets transferred by molecules. Now, some materials are definitely better at heat transfer than others. So like this floor here, the tile part is good at carrying heat energy away from your foot, whereas the floor is more of an insulator, so the heat stays in your foot. So one feels warmer. The temperatures of them are both at room temperature. Okay, now we talked a little bit about how heat will go from a hotter object to a colder object. And so here's a finger on a nail, which is stuck in some ice. And again, we talked about this, the heat flows out of your hand and into the ice, and then the ice might melt. What we call insulation is a material that slows the transfer of heat energy. It doesn't prevent it totally. I mean, it would be great if there was perfect insulation, and so you could heat your house up once at the start of winter, and as long as you're careful with the doors, you would hardly need to heat it again. But that's not what happened. Heat leaks out of the house. We don't have perfect insulation. And during the summer, you can't just cool down your house once. You have to continually run electricity to keep the heat out of your house, to pump heat out of your house from your air conditioning. So anyway, so yes, so insulation is not going to prevent heat from leaking in or out of things forever. It just takes a little longer. Now, good conductors usually have atoms with loose outer electrons. So metals are usually the best conductors of heat, just like they're the best conductors of electricity. And for the same reason, they have electrons that can flow and they can carry energy. Now, poor conductors or insulators, they often have trapped air because gases are good insulators compared to solids. And so things like wool, when you have a fuzzy jacket, what are you paying for? You're paying for the down, which is lots of tiny little feathers. And those little feathers are trapping warm air. And so that's how you stay warm in your down jacket. Um, So styrofoam, same thing, right? Little bubbles of air are trapped. Corks. So anyway, so things that are trapping air, those are good insulators. And here's a table just to show you a little bit about how the difference is between insulators. And you can see that the top the top conductors here are from silver through aluminum and steel and even into lead. And so you can see that those are all metals and they're all good conductors. Whereas we get to ice and concrete, those do some insulating, but not very well. And then we have other things that are even better, so like asbestos and wood and wool. Right? So there's your wool sweater there. That is not being able to carry much energy. So this is thermal conductivity is measured in watts that are so power, so energy transferring per second, and then there's units of thickness and things. Okay, so anyway, so some things are good conductors, and pretty much those are all metals, and then there are insulators, and water is an insulator as long as it's holding still. So that's one of the reasons if you ever get overboard in like Lake Michigan, where it's very cold, you're supposed to keep your clothes on because the clothes will trap layers of water against your skin that have already been warmed up. Take your boots off, because those are just going to drown you. But if you keep your clothes on, then you're better off than if you're naked, because then any heat you generate is going to be taken away by the water. So still water can be a good insulator. And this is one of the authors trying to walk across hot coals. And the idea is that these coals have been allowed to die down. So there is still heat inside them, but it's pretty much on the inside of them. And so the thing is, the wood itself that these coals are made of are insulators. So with the heat trapped inside, then you can actually walk across the hot coals. Now, if your feet get sweaty because you are afraid, then what happens is that then the little pieces of coals might stick to your feet and burn you. And so you have to be very calm to do this. Okay, now another way to transfer heat energy is called convection. Convection has heat energy that gets transferred from one location to another by the bulk movement of fluids and gases. So conduction was more for solids. Convection is where the molecules move and take the energy with them. And so bulk movement means millions and millions of molecules, so like ocean currents or air circulating in your house, billions of molecules. And so fluids or gases. And so there's some pictures here trying to illustrate this. So what we have is this is supposed to sort of represent your house. And you have a radiator. So it has hot water. And that hot water is radiating and heat is circulating around the room. And of course, most of us live in houses that have a furnace in the basement. And then we have vents all around carrying, so ductwork that carries that hot air. So we have to have a fan that pushes it around the house. This is a fry pan. Same idea. The heat's on the bottom, right? So the heat's on the bottom. And what happens is the water has to circulate. So remember when we talked about a pond with circulation? That was called convection. So that's the idea. Warm water will rise up, cooler water will go down, and the water will circulate until the whole pot is hot and boiling, perhaps. And this picture here is an interesting one. It's kind of showing what happens when a warmer liquid goes into a colder liquid. It stays together. So we were talking about the Gulf Stream. and how ocean currents like the Gulf Stream can transfer warm water for thousands of miles. So it stays together. It doesn't go into the ocean and instantly mix with other ocean currents. So you can have cold currents and warm currents that do transfer heat around the planet, as we already talked about once. And perhaps you have a convection oven. What's different about a convection oven is that it has a fan, and that blows air around in the oven so that hot air doesn't just rise past your food and stay at the top, but it circulates. And so remember, we talked about the Gulf Stream and how it carried energy up to Europe. Okay, and that's about all we're going to cover on conduction and convection. And next we're going to talk about radiation. So actually we're going to stop this part, and then we will start again with radiation. Okay, so you saw I make sure I stop.